We are filming. Please stand. And let us pray. In nomine Patris et Filii et Spiritus Sancti. Amen. Sancta Michael Arcangel, defende nos in prayer. Contra nequitiam et insidias diabolum, est presidium. Imbere Filii Deus, superceste pregam. Tuque princeps militiae celestis, Satanam aliosque spiritus malignos, quia in perditionem animarum pervegantur in mundo, divina virtute in infernum detrut. In nomine Patris et Filii et Spiritus Sancti. Amen. Dig out your yellow sheet, please. See what happens to that.
No, I mean, perfectly okay with that. Oh, yeah, it's fine. Fine that you cut off on it.
Check. Yeah.
That's good enough for me. You are.
All right. See you again.
Did you actually?
No, same. And then I also have like.
No, because what I want to do is
Oh, do you want to see the other worksheet?
Yes, please.
You're welcome.
Oh, I should. All right. Yeah, we could have both sheets out. I guess I didn't check this one out. It's a dream thing. I'm actually dreaming of calculus.
You're welcome. And she goes, and I go, and I don't have it anymore. I don't see what's wrong with that. That's funny. It's funny. I'm sweating.
So yeah, now the two worksheets, 2G and 2H.
What? I also. Anyway, then probably should like go home. I was like, I'm just done being. Like, I don't want to be anymore. She's like, I want to be what? Sad. And just like miserable. And she's like, are you so don't be? And I was like, yeah, that's
Are
great.
you Holly?
Yeah, if you do me a favor, the yellow one is supposed to say
she was just like,
2H.
just stop.
It says 2G.
I love
It says
I love that.
Literally,
change the,
someone's
change
crying.
the
And
yellow
they're like,
one to
I don't know what to
2H.
do. And they're like, just stop.
I know.
Okay.
Yeah, exactly.
It's like, just be happy. Just be happy. I want to just be
And make sure you have
Okay,
both.
but actually though, when you're like I'm worried, don't worry.
Yeah. No.
Like just stop.
I mean, honestly, the be happy thing, like, seriously, just being happy. I don't know how else to, you know? I know it, like, personally, like, it's a lot harder than that,
I'm like,
but. Julia,
I'm really trying.
I've tried that for, like, how many
Alrighty, face front please.
12 years.
Red writing utensil at the ready. For those of you listening at home, I know. Well, we're checking off the 2H, although the worksheet says 2G. The one that's yellow.
I
So
totally get it.
the answers are as follows. Listening, please. Gentlemen, we are starting with this in hand. Ready to whatever. But I mean, let's get moving. Number one, the limit is 0. Number 2, the limit is -1. Number 3, the limit is 1. Hope we didn't work too hard on that one. Number 4, the limit is -4. Hopefully that didn't stress you out. Number 5, the limit is negative cube root of 4. Hopefully that didn't stress you out either. With the possible exception of the cube root. No negative on the outside. Correct. The negative is on the outside. Now, if you had a negative on the inside, I'll actually accept it this time because it's the same answer. 6, 7, and 8 we skipped. Number 9, answer is 12. Number 10, the answer is 1 over 3 positive. Number 11, the answer is 0. I think we did that in class. Number 12, the answer is 0. Number 13, the answer is 1.
Wait, Mr. Captain?
Yeah.
Can you repeat 11?
11 was 0.
Okay. And 12 is 0?
12 is 0, and 13 is 1.
Okay.
Number 14, the answer is positive infinity. Number 15, the answer is positive infinity. Number 16, the answer is positive infinity. Number 17, the answer is positive infinity. Number 18, the answer is 2. Number 19, the answer is radical 2. I think we did that in class too. Number 20, the answer is negative infinity. 21, no limit. 22, negative infinity. 23, negative infinity. Don't forget the negative sign in front of the fraction there. 24, positive infinity. 25, no limit. Any repeats? 1 through 25. All right, questions? You guys want to see dissected? Now is a good chance. Good.
Should we go over 13?
13. Good job. All right. The limit as x approaches negative 3. Whoops. Limit as x approaches negative 3 overall of f of x. This at f of x is defined by the piecewise function. Negative x squared minus 6x minus h. Gentlemen, I would appreciate it if you didn't talk. By the way, back there. Can you just get over 2 desks, please? And that is if x is not equal to 3. Is that a 3 or negative? Negative 3. And it's equal to 4 if x is equal to negative 3. So they want to find the limit here. The only real way we can do this for piecewise functions is to graph it. Can somebody tell me the shape of the top? To graph it. It's a parabola, correct. We'll need to find the vertex or some critical points or something that'll help us graph it. Does anybody tell me anything about that parabola whatsoever? Something about it, yeah. It's opening downward, correct. How do you know? The height multiplier is negative. The lead coefficient is the height multiplier is negative 1. Is it taller, shorter, or normal height?
The negative. Yeah, well, it's normal, but it's upside down.
It is upside down. Why is it normal height?
Because the height multiplier is 1. Well, negative 1.
It's negative 1, correct. So it's not negative 2 or anything like that that would change the height. Can somebody tell me how to find any points on that whatsoever? Actually, if you look at this carefully, you should be able to give me 1 point immediately. It's just sort of leaping off the page again. See who sees it. Pretend this is y equals. What form is that, first of all? Go. 4. Well, no. Well, maybe. That's actually being sneaky. But that's true. By the way, it's a little bit more obscure. Well, actually, almost. I'll show you in a second. There's one you should be able to see right away. 0, negative 8. Correct. The y-intercept is always the last number in standard form. So there's a y-intercept of negative 8. Plug in x equals 0 and you'll see. Now, can anybody find the roots? Head up, please. How do you find roots, Michael? Don't look at the bottom one, just look at this.
How do you find roots?
Roots, correct.
Just plug it in. Plug like X in.
is a root? What's another name for a root? There are 4 possible words for it. Root is one. X-intercept. How do you find x-intercepts? Max? Sort of, kind of. That can help. How do you find x-intercepts in general? What's true about every x-intercept on Earth?
Well, I did like X minus 4, X minus.
Okay, so you factored it? By the way, if you factor, you'll have to do something first. What method of factoring you do first? GCF, is there one? -1. Then this will be x squared plus 6x plus 8. What does that factor into? Max, take over.
X plus 4X.
Correct. X was 4x plus 2. What does that make the roots? Julie Miller. What roots?
2.
Close. -4, -2. How do you find them? How do you find roots in any polynomial on Earth? Another name for root is a x-intercept. I just about gave it away. What's another name? Root, x-intercept, 2 more. 0 or 0 of the function, and that's an S. Solution. How do you find solutions? Solutions means you solve. Set it equal to 0. Technically, you're setting y equal to 0. You might want to write that down in your notes if you didn't have that off the top of your head. To solve anything, you set it equal to 0. To find x-intercepts, you set y equal to 0. Kind of like the chubby hand method. So we're going to set this equal to 0. Because if y is in front and you make it 0, it looks like this. And then if you do zero product property, you should get x equals -4, x equals -2. So it should be over here. Can somebody tell me anything else about this parabola? It's going down, and you can actually kind of see it has to go down in order to hit all 3 points. Can anybody give me anything else useful about that parabola? Us? John. Can we find the vertex? How? Give me can you see any clues?
We can have the points that are two spaces apart.
Okay.
So we know that it's the hypotenuse is normal. So
Hypotenuse normal, okay.
So we can kind of reverse engineer it.
Okay.
And go back to it.
How far over is the vertex? Like x equals what? I should have marked these. This is -2 and this is -4. -3. How do you get that? Let me see. Oh.
Well,
It's halfway in between any 2 x-intercepts. It's always exactly halfway in between. So it's -3 comma something. What's the something? Pete. -3 comma 1, correct. How do you get that? There are at least 2 ways you could do that.
I mean, the pattern is over 1, down 1, so you just kind of use that.
Correct. Over 1, down 1 means if you went backward, you have to be up 1, left 1, left, right 1. Correct. Another way you could do it is if you plugged in -3, let's just try it. Plug in -3, Max, help me out here. The original formula. What's -3 squared? Times -1? Yeah, remember -9 for a second. Somebody remember -9. What's -6 times -3? 18. What's 18 plus -9? 9. Minus 8? 1. That's okay. But did you notice that when you plugged in -3 for x, you got a 1 for y? That will always work. If you want the height of any point, whether it's a special point or not, plug in the value of x and you can get the y. So you should be able to see this. Now, It says it behaves like this if x is not negative 3. I need to make one change to my graph. Actually, two changes. Little changes. What does this do? What does this do? Do I have to change this parabola at all? Does it cease to exist somewhere? Yeah. At the vertex. The vertex is a gap. It's an open dot. Let me see why. They did not allow it. They shot it out. Michael, take over. There's one more point on this graph that needs to be graphed. Where?
So on the other side, we go,
Oh,
on the
not
left.
here. I know what you're doing. But there's a point that's like at negative 3. This says don't use negative 3 for this. But they did say use negative 3 for something else. Negative 3 comma 1 is not legal. But negative 3 comma something else is.
Oh, comma 4.
Yes. This surgically removed the point and moved it up to negative 3 comma 4. There's your graph. That one single point is dislocated. Those piecewise functions like to do that. So here's my question. What's the limit as x approaches negative 3? Go. Oh, sorry. What do you think? It is 1. Correct. How'd you get that?
They're going from both sides and I get 3.
Yeah. You notice it's heading toward, as you get closer and closer to x equals negative 3, y is getting closer and closer to 1. Does it matter that there's no target at the end? No. Limits
They
never
don't
get there
touch it.
anyway. Yeah, bingo. Is everybody clear on that? Because that will be on the test. There will be something where you approach both sides perfectly and the actual target is missing. That doesn't matter for limits. Limits never get there anyway. The limit is just saying, what are you aiming toward? Not what you actually arrive at. Clear? Next. Gentlemen, a little less random chit chat. Go.
So I was confused because of the point at negative 3.4. That doesn't change anything.
Correct. The funny thing, what it would change, if anybody actually asked, what is f of negative 3? That would be 4. Now, and that's, if you did f of negative 3.1 or something, it would be markedly different. There would be a huge jump. But the limit itself is blind to this. It's just saying I'm getting closer and closer and closer to negative 3. What's the height getting closer and closer to? It's getting closer and closer to 1. And it never even pays attention to whether you arrive or not. Yeah. So it is disconcerting. It's like, the answer's supposed to be 4, but it never gets there. So it gets deceived. Yeah.
Can you number
11.
11?
Yeah. Let me take a look. Oh, yeah. Let's see. Is there a problem, gentlemen? Okay. I do need a little more focus up here. The more distracted you get, the worse the test scores usually are. Calculus can be easy if you keep up with it. But if you lose focus, calculus can be brutal. The limit as x approaches 3 overall of x over 1 over negative 3 plus x plus 1/3. Can anybody recommend a method for me? I don't want to have a seating chart in calculus. That's rather ridiculous. But I'll do it if I have to. I'm trusting that as seniors, you know how to use self-restraint. Believe me, I have seen people crash and burn in calculus before. And it's not because they don't know how to do the stuff. It's because they unplug and distract themselves with other things. And then by the time you're one chapter behind, the rest of it is a disaster. Playing catch up in calculus is like trying to run up a straight wall. Good luck with that. It's possible, but special equipment and a heck of a lot of help. Don't do it. If you stay with it every single step of the way, calculus can be pretty friendly. Just stick with it. Okay. That's up to you. Any recommendations? Can somebody list the methods for finding a limit? What's the very first? Go.
Plug in.
Plug it in. Is that legal?
No.
Not in this case. Why not?
Cancel out, or let's say it will become 0.
Right. This will become 1 over 0 and explode. What's the next method? Factor it and see if something cancels. Is there anything to factor in there? No, there's nothing squared, nothing cubed, nothing to the 4th power. So there's nothing that looks like it'll factor at all. What's the next one? Common denominator. Does this look like you might want to do that here? Yes. Do you remember the method? Yeah. Crisscross across. Now leave the x on top. Crisscross across. Now keep the limit. We haven't calculated the limit yet, so you gotta keep writing that. Of x on top over what? Jack, go ahead and do it.
So it's x over 3 plus negative 3 plus x.
All
And then
over. And I would leave it in parentheses.
So you said you would leave it in
I would,
parentheses?
yeah. And
Yeah,
3
okay.
parentheses.
And 3 parentheses, x minus 3.
Yeah, actually that looks good. X minus 3. Did you ever see where this top came from? The crisscross is the multiply. 1 times 3 is 3. And then 1 times this stuff is this stuff. And then on the bottom it's 3 times this. Why didn't I distribute and put negative 9 plus 3x? I could have. But I'm hoping to have something cancel. So anything else happen? Pete, take over.
Well, the 3 and the negative 3 on the bottom cancel.
Correct. So what do we do now?
So then,
Remember, this is a fraction on the bottom.
well, you can rewrite it.
How so?
You can just do x over, and then x over 3 parentheses x minus 3, and the parentheses are on the
Okay.
whole bottom.
Okay. Now what? That's correct, by the way. Max, take over. You can, but we just talked about that. We're hoping to have something cancel. And if it doesn't cancel, it's not a big deal. I would leave the bottoms unfactored, like forever in any of these problems, until the bitter end. Yeah.
You can multiply the reciprocal.
Yeah, you know, dividing by a fraction is the same as multiplying by the reciprocal. What does that do? Michael?
So 2x's cancel.
Correct. X's will cancel. What's left? The limit as x approaches 3 of what? What still survives? Don't calculate it yet, but just give me a point.
X.
I missed something. This is canceled.
Oh, I did see. So it's just 3 parentheses x minus 3.
Yes. What now?
Wait, why did that cancel?
Oh,
I understand
this
how, yeah, how did that cancel?
became multiplying by the reciprocal. Dividing by a fraction became multiplying by the reciprocal. And then, so this is gone, and then these x's canceled and left with that. So what now? I can finish it up. Is it legal to plug it in now?
Well, yeah.
Which one?
Well, you get 0.
You get 0. When is 0 a problem? 0 is actually a perfectly legal number, except when it's where? Go. When it's on the bottom of a fraction. Right, there's no more fraction. So yeah, getting a 0 is a little alarming, but it's not illegal. Because a lot of these do have an answer of 0. The only time you have to worry about that is that it's in the denominator. So the answer on this one, the limit is equal to 0. Yeah. Any other ones? Yeah. Number 9. Okay. There are 2 ways. Did anybody catch the fast way to do this? The factoring way to do this? It's sneaky. I'll show you if you want. Just out of curiosity, did anybody see it? Don't feel bad if you didn't. It's sneaky by definition is something that doesn't occur naturally. It's x minus 30, it's the limit as x approaches 36. This is number 9. Of x minus 36 over, is it radical x minus 6? Keep in mind the minus 6 is not in the radical. I'm actually going to show you the long way to do this. First, I'm going to turbo this because it takes a while. There's a radical in the basement. So, get the radical out of the basement. Normally, we don't care about that in calculus, but if I plug it in, it blows up. I got to do something. And there's no factoring that I can see, obviously. So, and there's no common denominator. Normally, rationalize, you get the radicals out of the top. But this one might be an old-fashioned get it out of the bottom. Using the conjugate, radical x plus 6. I'm going to quick multiply that. And again, I'm going to keep things more or less in parentheses. The top is going to be x radical x plus 6x plus negative 36 radical x minus 216 all over x plus 6 radical x minus 6 radical x minus 36. Now, these cancel. That actually doesn't do much. Tell you what, I'll show you the way I did it. It's actually really fast. Think about that for a second. X minus 36 over radical x minus 6. The top, believe it or not, factors. You can see this more clearly if you use something called substitution. If you do u is equal to radical x, this becomes the limit as, actually, this is a good practice for next chapter. Yeah, good question.
I was just going to say, what I did is I left the top unfactored and then just canceled out the x minus 36x.
Oh, I see what you're doing. You're brilliant. Yes. That's actually awesome. Thank you. You just saved my bacon. I did it at like 10:30 at night, which is what I tell everybody not to do. That's probably why. So this is x minus 36. Leave the top, and then the bottom cancels out to x minus 36, which, bang. Yeah, that's nice. Now you can plug in 36 into here, so it'll be radical 36 plus 6, which is 6 plus 6, which is 12. I'll show you an even faster way than this method of substitution, but just as good practice. Next chapter especially, and the chapter after, we're going to be using what's called U substitution a lot. It's going to be a standard trick in calculus. There's some problems that you cannot do it without doing this trick. If U is radical x, and x is going to 36, what's U going to? This is a little mental challenge. What's that? 6. I'm going to rewrite this. See what I just did? It looks like that can't be legal. It is. As long as x is going to radical 36 and u is the square root of that, u has to be going to 6. Makes sense. Of what? What is this thing? What is it? Well, actually, let's do the bottom. What is radical x? Visualization. Not the number yet, but formula-wise, I mean. U. So if radical x is u, what's regular x? This is actually from substitution for factoring. What do I put in place of x? If radical x is regular u, what's regular x? U squared. Let me see what happens now. Look at the top. Jack, go.
It's u minus 6, u plus 6.
What happens now?
The u minus 6 is canceled.
Correct. What's left?
You got
this in legally?
Yeah.
Do it.
6 plus 6 is 12.
Got it. Makes us 12. Yeah. The third way, which is the fastest, but it's kind of the hardest to see, the limit as x approaches 36 of x minus 36 over radical x minus 6. It's hard to see because people look at the top and say that doesn't factor. If you pretend this is something squared, it does. It's radical x plus 6, radical x minus 6. Cancel, cancel, log 12. Again, that's tricky. But if you know, like if I gave you this, like m minus 49, could anybody factor that for me? You did 2 parentheses. It actually does, as long as you don't limit yourself to nice variables. What do you think? Actually, Polly. There's going to be 7 and minus 7 and plus 7, definitely. What does m split into? M squared would split into m and m. What does regular m split into? Yeah. I'm lucky. Good. What times itself gives you m? Do you want it? Go. Yeah. Square root of m. Square root of m. See the trick? That always works. It's weird. People say, why on earth would you do that? I wouldn't usually, unless there's a special case for something nice. Any others? Yeah.
Can we look at 18 and 19, please?
18 and 19,
I think we're
yeah.
out of time.
How much time do we have? Yikes! We have 0 time. So, yeah, welcome to the special schedule day. Merry Christmas. Don't get used to it. We don't have homework for tomorrow. You're welcome, Noah. Tomorrow we'll finish off the notes on this. We will have one more worksheet. That, by the way, will be the last homework of the chapter, which means that the chapter test is looming on the horizon. So brace yourself for that. Everything you ever wanted to know about limits, but we're afraid to ask. Please stand. And let us pray. We're about to get invaded. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Glory be to the Father, to the Son, and to the Holy Spirit, as it was in the beginning, is now, and ever shall be, world without end. Amen. In the name of the Father, and the Son, and the Holy Spirit. Amen. All right. See y'all later. Bye. Okay. Here's it.
Bye. Bye.